with the first question. It goes like this. Two circles of unequal radius have four common tangents. The transverse common tangent meets the direct common tangent at the point P and Q. If length of direct common tangents between the point of contact is 8 and the length of PQ is. This is a very good problem based on basics. So let's start with the circle. Since we have two circles having four common tangents, it's appropriate to draw a rough diagram neatly. Okay. So let's draw direct tangents first. And the transverse tangents. So direct tangents are those which are on the same side of the center, right? Transverse tangents are those which are on opposite side of the center. So clearly from this diagram you can see like this is transverse tangent, transverse common tangent with these two circles, and these two are direct common tangent, DCT and TCT. Right, now according to the question, they are given some information. The transverse common tangents meets the direct common tangent at point P and Q. So this point is, let's say, P, and this transverse meets the red guy at Q. Now we have to find the length of PQ. We need to find length of PQ. And what is given? Length of direct tangent between point of contact is 8. So we already know this length is given to us. So let's say this point is R, and the point of contact of red guy from first circle is S. We can even give a numbering, let it be U, B, this is W, and this is T. Now suppose if you start with a general circle, okay, and which is not intersecting, because if two circles intersects, we'll have only two common tangent, right? If two circles are touching each other internally, we'll have one common tangent, which is basically DCT, because this tangent is on the same side of on the right of the center. Even if two tangents intersect externally, we'll have three common tangents like this, right? So you can tell this is TCT because this common tangent is on other side of the centers are on the either side of this line. This is TCT. And if one circle is completely inside other, we'll have no tangent, right? And if they are separated, we'll have four common tangents. So of course, from the given statement of problem, only this diagram is possible, right? Okay. Now again, method 1 can be, you can come with a general center and general radius for first circle, and general center and radius for the second circle, and do all the calculations, calculate those coordinates and get the answer. Of course, by looking at the simplicity of the problem, we are tempted to solve it in a pure geometry style. Okay, so in circle chapters, instead of directly going to the coordinate, if the question mentions more about coordinate systems or the equations, then definitely coordinates should be your first idea. But if it is a general circle, then we can definitely use basic property of circles to get to the region. ठीक है, तो यहाँ पे आप सपोज ये पी आर का लेंथ को हमने x ले लिया. ओके, लेट्स टेक लेंथ ऑफ पी आर को x ले लिया एंड लेंथ ऑफ एस पी y. तो टी पी का लेंथ इज ऑल्सो x, राइट? Now what about VT length? Since we know on a circle, tangent drawn from the external point will have equal in length because of the symmetricity, half-fold symmetricity of the circle. Okay, so I can tell SP is equal to VP. So that gives VT equals Y minus S, because PS and PB is same, right? So this part is X, so this remaining will be Y minus X. Similarly, what about WQ and QB? So you can take WQ, let's say, as Z, and QB will automatically be Z because length of tangent will be equal. So from point Q, two tangents are drawn to the first circle. Now what about this remaining length, QB? So again, QB will be equal to QT, right? QB equal to QT by half-fold symmetry or by congruence, because length of tangent are equal. So that will give QB equals QT, and QT is how much? Y minus X plus Z. So Y minus X plus Z. And now we have an interesting result now. So since we know again with respect to this point, the length of tangent will be equal, right? So S with this point and W with this will be equal. Similarly, these two distances are also equal. Okay, let's call this point is P. P we have already taken, so P dash. So again, the distance of P dash from first circle is equal, and distance of P dash from second circle is equal. Hence, this distance will also be same, right? So that gives us a very interesting result. Is PS equals WB. Okay, PS equals WB. Now what is PS? X plus Y by our notation. And what is distance in W and B? Is Z plus this extra part. So Y minus X plus 2Z, right? Z plus this value, Y minus X plus. And very interestingly, what we are seeing here is 2X equals 2Z. That gives X equals Z. It's literally surprising result because no matter what two circles you select, okay, the tangent drawn from the point to the either circle where the transverse common tangents meets the direct common tangent is equal in length. So these two guys and these two guys are equal in length. Okay, it might be very obvious. It might not be very obvious because this is the smaller circle, right? And this is bigger circle, but still these two lengths are equal, and that we have proved it. So hence the answer to this problem we have already got because we wanted PQ. So PQ value is nothing but X plus Y minus X plus Z, and since Z is X, so XX will get cancelled. It's X plus Y, and X plus Y by our notation is RS. So that's length of direct common tangent. So PQ distance is same as RS distance. Hence the answer to this problem is 8. So this is a good problem which shows you how to apply the basic concept in order to solve certain P. On the circle S1, so we have got two circles. One is S1 having center 0, 0 and radius 3 root 2, right? Root 18. We have got another circle S2 which is concentric with radius 2 root 2. Now let's say we have a from any point P on the circles, let's take a general point P on the circles. Tangents are drawn to S2. Okay, and these tangents meets S1 at Q and R. Further, the locus of point of intersection of tangents drawn at Q and R to the circle S1. So on a bigger circle, we have to again draw the tangents, and they'll meet at a point R. We need to find the locus of point R. So before we go to the solution, you must understand, if I fix a point P, since circle is fixed, the tangents line will be fixed, right? Hence Q and R will be fixed. Now at a fixed circle S1 and at a fixed point R, the tangents QR and R, let's say RS, this is also fixed. So if I fix a point P, point S will be fixed, right? Okay, so for a given point P which is fixed in a circle, clearly PR and PQ is fixed. Tangents at R and Q will be fixed and the point S is fixed. So as P changes along the circle, the point S will also change accordingly. So point S will move on a curve. You have to find the relation between X and Y coordinate of that curve. That is fundamentally the meaning of locus. Okay, so let's solve this problem. Now obviously from the symmetricity of the question, you can see if I connect point P with the center, it will definitely pass to the point S also, because exactly still this is the line of symmetry for the entire situation, right? So point P, O and S has to be coordinated. Now we have to find the configuration for S. One way of solving this question could be you take a point P as, let's say, 3 root 2 cos theta and 3 root 2 sin theta, right? Some random point. From here you draw the pair of tangents line SS1 equals t square, and maybe you solve the pair of tangent, okay, with the circle S1, get a point R and Q. Once we get R and Q, we can again find the tangents line to the circle S1 at those 2 points and find the point of intersection. And point of intersection alpha and beta will come in terms of theta, right? And then eliminate theta using sin square theta plus cos square theta equals 1. We'll get the relation, and that will be the answer. Now since options are so nice, like it's circle, and moreover this approach will be time taking. Okay, so we can still think of another approach. આવે છે 5 મિનિટ બેઠું 10 મિનિટ में આવે છે. Let's think of other approach. So maybe RQ, can we find the chord RQ directly? Okay, actually we don't know the point R and Q, and there is no guarantee like RQ is tangents to the circle S2. Okay, with respect to point S, with respect to point S, RQ is the chord of contact. With respect to point S in circle S1, RQ is point of chord of contact. So let's say S, if I take alpha comma beta, then the equation of RQ is known to us. It will be T equals 0. Okay, so this I am discussing approach number 2. Now again T equal to 0, I can solve with S1, and at those 2 points, okay, we'll from that 2 point we can draw the tangents to this circle. So one of the tangent will be this itself, other tangent will be this, and the point of intersection has to lie on the circle itself. Okay, so I'll find the equation of PR and RQ once we got RQ directly this way, and finding the equations we'll get point P. Okay, that point P will come in terms of alpha and beta, and that must satisfy the equation of the circle S1, which is x square plus y square equal to 18. So again we'll get a relation between alpha and beta. But that method seems still lengthy, right? That method seems still lengthy. So is there any smart way of doing this? Is there any smart way of doing this? Okay, fine. Then maybe your thought process will be is if I connect, right? Because the chord of contact idea is giving a lengthy approach of solving this problem, right? So let's try to think it geometrically. So we'll see the geometrical solution of it. So let's solve this problem geometrically. So we have got S1, S2, any random point P, tangent drawn meets at Q and R. At point Q and R we draw a tangent, it meets at S. From half-fold symmetricity of the problem, clearly POS is a straight line. Okay, so basically we have to find the relation between the x and y coordinate of point S. That's the meaning of locus. So let's call this angle as theta. So this will also be theta by the half-fold symmetricity or congruency. What about this radius? So this length is already 2 root 2 and OP is 3 root 2, right? So that gives me sin theta value. Sin theta is perpendicular 2 root 2 by hypotenuse. So sin theta we are getting 2 root 3. Now using this, we have to relate the length OS and RS, right? So if I join O with R, you know this angle is going to be 90 degree. So because to get length, we need to come with some triangle, right? In a triangle, we'll have angle changing, and that will give distances. So sin theta is already known to us. It's 2 by 3. Now, if this angle is theta and this is 90, right? So what about this angle? 90 minus theta. Since this is isosceles, because OP equals OR, so this angle will be theta as well, right? Hence, angle SOR is going to be 2 theta, because this is external angle for the triangle OPR. So theta plus theta is going to be 2 theta. So now you consider triangle ORS. In triangle ORS, we have some basic 2 theta length is already known. Okay. Radius is known, that's capital R, which is 3 root 2. So how to find this distance? OS. Why we are interested in distance OS? Because O is fixed point. If I calculate RS, R is not fixed, neither S is fixed. Okay, so it's better to calculate distance from at least the points which I have fixed landmark. इफ यू नॉट गेटिंग एनीथिंग देन ऑफ कोर्स यू डोंट हैव ऑप्शन, लेकिन यहाँ पे अपने पास ऑप्शन है। तो ओ फिक्स पॉइंट है, तो ओ एस का डिस्टेंस अगर मैं कैलकुलेट कर, तो ओ एस का हाउ विल यू कैलकुलेट? ओके, सो tan to theta is perpendicular by base, right? So tan to theta with respect to this triangle is perpendicular by base. तो यहाँ पे perpendicular कौन सा आया? This is hypotenuse, right? So if I'll use tan to theta, we are gonna get OR by RS. So that will not give the relation to OS. Cos 2 theta is base by hypotenuse. So here I can write cos 2 theta is base, which is OR, which is radius 3 root 2 by hypotenuse, which is OS. So from here OS value we are getting 3 root 2 by cos 2 theta. Now we already have sin theta with us. So cos 2 theta calculation is simple. That we can calculate as 1 minus 2 sin square theta, right? So it will give you 1 minus 2 into 4 by 9, which gives you 1 minus 8 by 9, and we have 1 by 9. So cos 2 theta value is 1 by 9. That will give you 27 root 2 as the value for OS. Now once OS is 27 root 2, question is done, because O is a fixed point, 0, 0, and S is alpha comma beta. So from here we can easily see like distance OS is 27 root 2, which implies alpha square plus beta square root 27 root 2 implies alpha square plus beta square is 27 square into 2, and that gives you option as 145. This was again a good questions where coordinate geometry approach will seem lengthy, so you can basically connect with angle change. Okay, the assignment for you is you can try to solve this question even with this chord of contact. Okay, so that's a pure coordinate geometry approach where with respect to point S, QR is a chord of contact, okay, to the circle S1. And then you can see like QR also served as the chord for like QR is also the line at which PQ and PR intersects. So maybe from here you can get something, because little bit hint I'm giving for you for method 3, right? Method 3. So you can write PQ and QR. So equation of pair of tangents you can write SS1 equals TA square. So let's take, if I take any random point P, 3 root 2 cos theta, comma 3 root 2 sin theta. With respect to point P, I can write the joint equation of pair of lines. Now with this joint equation of pair of lines, I'll solve the circle S1, right? So if I'll solve this both of them, so you will get a second degree curve over here. We'll have a second degree curve, which is already circle equation. So x square plus y square equals 18. Now if we'll subtract both equations, so definitely we'll get a line which passes through this two, right? Subtract where you try to eliminate, okay, the coefficient of x square y square, so that directly we'll get the equation of line PQ. And now equation of line RS, you will get the equation of line RS. Okay, so the other approach is SS1 TA square. We'll write the joint equation of PQ and PR. Now if we'll solve this with the circle x square plus y square is 18, by eliminating x square y square, that will be easier to eliminate. You can directly get the equation of line RQ, right? RQ. Now this equation you can find from the chord of contact principle. So with respect to S, we can find QR from chord of contact. Just equate both equations because both represent the same line. So by taking their coefficients to in proportion, you'll get exactly the circle. So this is left as an assignment for you. I'm sure like you'll have fun doing that. Let's move to the third question, last question for today's session. So we define a region in the XY plane as corona free. This problem we have created when COVID was there. So if for any 2 points x1 y1 and x2 y2, the point x1 plus 3 x2 by 4 and similarly for Y also lies in the same region. So which of the following is not corona free? So let's understand the question first. What is the significance of corona free region here? So for any point, let's say if I have got any point P1 and other point P2 in some region, let's call this is some region R. Okay, so how I'll be sure like this region is corona free? So there is no COVID case in this region. If the point given by x1 plus 3x2 by 4 and y1 plus 3y2 by 4 also lies in the same region. Now what is the significance of these points? Is 1 times x1 plus 3 times x2 by 1 plus 3, right? So this point is basically a point which divides the join of P1 P2 internally in the ratio 1:3, right? So it's x1 y1 and x2 y2. So this point P is a point which lies on the line joining P1 P2 and internally divides in the ratio 1:3. Okay, so is this given region corona free? So you can little bit experiment. Let's say if I pick up any point P1 from this corona COVID region and another point P2 from COVID region, so of course the point P will lie somewhere along the line joining P1 P2. Okay, so it can't go outside. So with P1 fixed, if you'll play with P2 anywhere, I know like these P's are still in this region. Okay, so this sample region feels like it's corona free, right? Because if you pick up any random 2 points, let's pick up point 1 and point 2 as well as they are in corona free region, the point P is definitely in between them. Okay, so there is no way it can go not corona free. What about region? Let's say if something like this is there. Okay, now can we think? Let's say if you have point P and Q, so of course the point R which divides it in 2 is to 1 is corona free. But if I select point P here and other point, let's say P2 here, now the point P might not be in the corona free region. So for this kind of curve, you see it's not guaranteed like the P also lies in the corona free. So P is having COVID case now because this region depicts corona free region and point P can be outside. So from here, from this basic idea, a sketch of the situations, now you can easily answer the following. So option A, if you decode, it's a disk, right? Everything inside this circle. And because it's bending inside, okay, so if I pick up any 2 region, you can convince yourself the third point is also will be within the same region, right? What about, so option A is already corona free. So we don't want, which of the following is not corona free. What about option B? This represents the ellipse. So x square by 1 plus y square by 1 by root 2 whole square is less than equal to 1. So if we plot the equality case, we'll have ellipse something like this, right? So again for ellipse, if I pick up any 2 points, it's quite obvious. The point which divides in the ratio 1:2 will also be inside. You can take any situations and point to inside. So this is also a wrong answer because we want corona free, right? Third is x square by 1 minus y square by 1 is less than equal to 1. So it's hyperbolic case. So for hyperbola, you can put x0. First solve for the equality case. Even if you don't know hyperbola, put x0 y equals plus minus 1. So that's not possible. So hyperbola will be something like this, right? Now what is less than equal to 1? So less than equal to region will be here because we can take some point and you can check over it, right? Because let's say if x is 0 or let's say if y is 0, so x has to be between -1 to +1, right? If I'll keep y0 in this equation, mod x must be less than equal to 1. It means you must oscillate in this region. So this is a region which is depicted by this hyperbola. Now again, if I pick any 2 point P and Q, so point R is in corona free region. But what if I take point P over here and point Q over here? So now this point is definitely not in corona free region. What if I take point P here and point Q here? So maybe 2:1 will come here. So that's not a corona free. Okay, so if I take any 2 point, maybe, okay, P1 and P2 over here, the third point P can be outside this corona free region. Okay, so this region C is not corona free. What about y square less than x? So y square equals x is basically parabola. Less than equal to is this region. Again, you can pick up any 2 points and you can see here there is no danger of the line joining any two to be outside. So this is still corona free. So answer C is the correct answer for this problem. Okay. If some of you feel like solving this problem in a pure coordinate style, still it can be done. So x square plus y square is less than equal to 1. So x square plus y square is less than equal to 1 depicts this region. You pick up any point x1, y1. Since it belongs to this region, so x1 square plus y1 square will be less than equal to 1, right? Similarly, you pick up any other point x2 square plus y2 square will be less than equal to 1. Now using this relation, you try to prove that x1 plus 3x2 whole square by 16 plus y1 plus 3y2 का whole square by 16 will also be less than y1 plus 3y2 का whole square by 16 will also be less than. Okay, so these two must imply this. So that actually you can prove from the pure algebraic style. Okay, because you can use a plus b whole square is a square plus b square to ab, and you can manipulate to get this result. Similarly, in a pure coordinate style you can do, but conceptually you can simply draw diagram and have a feel of the situation. Next is, suppose two region R1 and R2 are corona free and R1 and R2 is not phi, means there is common between those two regions. Okay, then which of the following must be corona free? So if there is two regions which is corona free and they have a non-zero intersection. Okay, so let's say this represents R1, we have another region R2, and they have non-zero intersection. So there is something counting them, right? If these two regions are corona free, then can you tell R1 union R2 is also corona free? No, first is wrong, because clearly from this diagram you can see if I pick up point P over here and Q over here, so there exists point R dividing in 1:3 ratio, which is not belonging to the same region. So first option is wrong. Second is, what about R1 intersection R2? What about common region? Okay, so with respect to this diagram, again we can clearly see if I pick up any 2 points R1 and R2, the other point is also in the COVID free region. So this was a good question. The third part of this question is, let R1 is maximum of mod x mod y less than equal to 2. So what is maximum of any two number? Let's say maximum of 1 comma 2 is 2. Max of 1 comma 1 will be 1 only, right? What is max of x comma y? That depends. That depends which is more. So if x is more than y, maximum of x y will become x. If x is less than y, maximum will become y. And if they are equal, then it can be anything, whether you call x and y, doesn't matter. Now the maximum of mod x mod y is less than equal to half. So first let's plot the graph of maximum is equal to half, equality case. Whenever you have inequality, you take the equality case. So maximum of mod x half means x will be plus minus half. Similarly, maximum of mod y equal to half will be y will be plus minus half. Okay, so can you give the one example for this? It means, let's say maximum of if I am taking half comma half, so x half and y half will satisfy this equation. If I take max of 1 and half, so that will be half, so that will not satisfy this case. It means all the point having x and y coordinate in this region will satisfy this, right? Because if I pick up any point, okay, its x and y coordinate will definitely be less than half. So its maximum will be, whatever will be more, it will definitely be less than or equal to half. So this is the region which depicts maximum of x comma y less than equal to half. Maximum equal to half is basically line of control. So it's the boundary line, right? Boundary line. And R2 is x square minus y square is less than equal to 1. So what is R2? This is basically hyperbola. So again, you don't need much concept for hyperbola to solve this question. So for equality case, you can draw the curve. So if y 0, x will be plus minus 1, right? So this point is half comma 0, similarly minus half comma 0. So at y 0, x will be plus minus 1, and at x 0, nothing like this. So there will be no part of the curve. So hyperbola will go like this, right? And now you have less than equal to 1. Less than equal to 1 means this region. Less than equal to 1 means if y 0, x will be between minus 1 to plus 1. So we have basically this region for the second curve. Now the question is the area of common region in R1 and R2 which are corona free. Okay, common region between R1 and R2 which is corona free. So of course this entire region is corona free because this square you can think if I pick up any 2 points, the third point has to be there, right? So it is just this area, so it's nothing but half plus half 1 into 1, that will give 1 and 1. So this was still a good question on application of this COVID region. Okay, so with this we finish this. I'll come with more interesting questions like that.